Hey guys, my name is Kaylin Chapman, and today we will be talking about the bioanalytical technique that is used to determine if you have the COVID-19 virus. So you go to get tested. They take a nose swab, and then later that day you get a call. That call says that you tested positive for COVID-19. Well, how does a nose swab detect if you have a virus? This is because of a bioanalytical technique known as polymerase chain reaction. Well, what is PCR? It is a bioanalytical technique that is used to identify bacteria or viruses in a sample. It has the ability to make several copies of small segments of DNA, and it is also used for genetic sequencing and generating forensic DNA profiles. There are 3 steps to PCR. The first step is denaturing or strand separation. The second step is annealing, and the third step is extension or elongation. The core principle of PCR is to use an enzyme called DNA polymerase to make a copy of a DNA strand. DNA typically exists as double-stranded, but DNA polymerase can only work on a single strand. So it is necessary to separate the strands using heat. Applying heat denatures the double strand into a single strand. Now the enzyme can work on the single strand to make a copy. But the enzyme needs a small region of a double strand to get started. To do this, a primer is added. The primer is a short piece of single-stranded DNA that binds to a specific piece of the single strand, creating a double strand. This is part of the annealing step. It is fully achieved by cooling the mixture. The DNA polymerase begins copying the single-strand molecule starting at the bound primer region, and this continues and elongates the DNA. Both single strands of the original double-stranded DNA molecule are copied, and this is repeated around 30 to 40 times. This is creating longer strands of the original double-stranded DNA. This is necessary since molecular and genetic analysis requires a significant amount of DNA. But there's one problem when it comes to COVID. So COVID is a single-stranded RNA virus. So we have to do something that is called reverse transcription. Reverse transcription is converting RNA to DNA because only DNA can be amplified or copied. The sample is taken from the nose, treated with solutions that remove proteins and fats from the sample, and it extracts the DNA. The DNA is then put into a test tube with reverse transcriptase, random primers, DNTP mixture, water, buffer, and an RNA template. Reverse transcription then happens, and then you are left with cDNA. That cDNA can then be used with a polymerase chain reaction to create long strands of that COVID virus. So here's a sample of the polymerase chain reaction. So you have that now cDNA from the COVID virus, and then we are going to denature it. So we separate it into these 2 strands. We then add our primer, then the nucleotides are added, and then we get our elongated copies of our DNA. There are many advantages to PCR. There is high sensitivity compared to culture and stain, and it has the ability to test for microbial resistance. It is more cost-effective for selective use compared to cultures and stainings. It has an increased ability to detect less common organisms such as viruses. Disadvantages include potential lower specificity compared to culture and staining. It can lead to more false positives. Possible microorganisms have to be known because specific primers are needed to run different PCRs. Sometimes a primer can bind nonspecifically to multiple locations. The test itself can be cost efficient, but the specific instruments and special training is not as cost efficient. That concludes our video on the bioanalytical technique of polymerase chain reaction. I hope you now understand everything about a PCR. I also hope that you never receive the call that you tested positive for COVID-19. Stay healthy.